For a long time, C/2023 A3, Suchinchen Atlas, was little more than a frantic blur of coordinates and plots, hurtling through our solar system at a staggering velocity. It was fascinating, certainly, but felt mostly theoretical. Then, quite suddenly, the momentum shifted. While the object didn't slow down, the flow of information did. Precisely when it mattered most, our telescopes lost their line of sight. Data streams cut out, and in the resulting silence, speculation went viral. When the object finally emerged from the sun's shadow, it had transformed. Its chemistry was different, its luminosity had spiked, its hue had shifted, and it was emitting signals never before recorded from an interstellar visitor. This was no longer just a routine passage. It was a fundamental challenge to our understanding of objects born in other star systems. What Suchinchen Atlas revealed compelled astronomers to stop, rethink, and, in many instances, completely overhaul their previous theories. A blind spot in the glare. By October, the global scientific community was finally prepared to conduct a rigorous study of the visitor. It had reached a point of sufficient brightness and proximity to allow for deep analysis. Ground-based observatories had already noted its peculiar molecular makeup, witnessed two distinct color changes, and debated a mysterious feature pointing toward the sun. However, just as the mission reached its zenith, the sun intervened. From our vantage point on Earth, the object disappeared into the solar glare exactly as it began to endure the most intense thermal stress of its journey. This is the moment where comets typically either disintegrate, flare up, or reveal their true composition. Instead, we were left in the dark. For weeks, terrestrial optical telescopes were useless, creating a gap in data where certainty vanished and rumors took hold. The view from deep space while Earth was blinded, our planetary neighborhood was watching. Positioned throughout the solar system, a network of spacecraft occupied the perfect vantage points to observe the encounter. Using coronagraphs on Stereo A and the recently launched GOES 19 to create artificial eclipses, these instruments filtered out the sun's light to see what was happening in the heart of the glare. When this data was later synthesized, the findings were shocking. For months, the object had followed a standard brightening curve. But as it crossed within 2 astronomical units, that curve didn't just sharpen, it broke. The brightness began to climb at a rate that defied all traditional models, signaling a massive, violent loss of material. This wasn't simple sublimation. An internal engine had been ignited. The fire hose effect, even before it ducked behind the sun, Suchinchen Atlas had signaled that it was anything but ordinary. NASA's Swift Observatory picked up a massive discharge of hydroxyl radicals, the byproduct of sunlight tearing apart water molecules. Despite being nearly 3 times further from the sun than Earth, where it remains freezing, the object was venting water at a rate of 40 kilograms per second. It wasn't a leak, it was a fire hose. Standard physics suggests ice shouldn't be that active at such distances. The takeaway was startling. Rather than a gentle surface melt, the object appeared to be violently ejecting icy grains, which dramatically increased its surface area and amplified its activity. Then, just as the scale of this phenomenon became clear, it vanished into the solar light. Peeling back the layers when the object finally reappeared, it wasn't just brighter, its very identity had shifted. For months, it had sported a reddish tint, common for surfaces rich in dust and organics. Later, it turned green, a sign of specific gases reacting to sunlight. But the solar observatories caught a third state, a distinct blue hue. This blue signature is the hallmark of volatile gases like carbon monoxide. It indicated that the sun's ferocity had stripped away the dusty outer skin, exposing a violently outgassing core. We realized the comet we had been tracking initially was just a shell. Only after the solar flyby did the true engine beneath the surface reveal itself. That a view from the red planet shortly before its encounter with the sun, the object performed a remarkable maneuver, passing within 19 cents of Mars. This gave the red planet a front-row seat to a historic event. For the first time, an interstellar visitor was being monitored not just from Earth, but from the perspective of another world. NASA's Mars Reconnaissance Orbiter pointed its HiRISE camera, an instrument capable of spotting a coffee table from orbit, at the visitor. Hopes were high that we might finally see the solid nucleus. However, the images revealed a different reality, a fuzzy 1,500 kilometers wide shroud of gas and dust. The core remained hidden behind its own chaos. Yet this failure to see the heart was actually vital data, confirming that the activity was so intense it completely obscured the object's physical center. The first multi-planetary target Mars orbiters weren't the only witnesses. ESA's Mars Express and the ExoMars missions joined the observation, while MAVEN captured a massive hydrogen envelope stretching far beyond the visible coma. Then, a true historical first occurred. On the surface of Mars, the Perseverance rover turned its cameras upward. In long exposure frames, the object appeared as a ghostly streak against the Martian stars. While subtle, the meaning was profound. Humanity was now tracking an interstellar traveler from two different planets simultaneously. It was no longer a distant. It was a multi-planetary target that left its mark across the entire solar system. Survival against the odds as the object emerged in November. The scientific world held its breath. The surge in brightness had been so extreme that many experts, including Harvard's Avi Loeb, suggested the object might have shattered into pieces. Given the implied mass loss, it seemed impossible for a standard comet to stay in one piece. For a few days, it felt like we might have lost our most important subject. But as data arrived from the Lowell Observatory and the Virtual Telescope project, the anxiety subsided. There was no debris cloud or trail of fragments. Against the odds, the visitor had survived. What looked like an explosion was actually a violent shedding of its outer layers, suggesting a nucleus far more durable and dense than anything we had expected. The propulsion controversy survival, however, didn't end the debate. It fueled it. Loeb and others pointed to two remaining anomalies: a persistent jet pointing toward the sun and a non-gravitational acceleration that kept the object on a strangely linear path. Some argued that the thrust required for such motion exceeded what natural outgassing could provide, bringing the idea of artificial propulsion back into the fold as a serious question. Others countered that sunward jets and the rocket effect from asymmetric outgassing are well-documented natural phenomena. The community was split not on the data itself, but on how to interpret the extreme levels at which these natural forces were operating. The radio evidence the deadlock was finally broken by radio astronomy. The Meerkat Array in South Africa detected specific absorption lines, the unmistakable fingerprint of water. Because radio waves penetrate dust, they provided a clear look at what optical telescopes couldn't see. This confirmed that the object was indeed venting massive amounts of water vapor. It was the first time radio emissions had ever been caught from an interstellar object, grounding the debate in physical reality. Whatever else it was, the visitor was fundamentally icy and chemically familiar. The most exotic theories lost momentum as the evidence became more refined. The rocket effect confirmed with water confirmed. The focus returned to its trajectory. A new dynamical study of its path over the last century showed that the acceleration was perfectly consistent with the rocket effect. When an object ejects mass asymmetrically, it receives a push. In a high-speed, hyperbolic orbit, this push appears more linear to an observer. Once the proper reference frames were applied, the visitor followed the laws of Newton and Kepler to the letter. It wasn't defying gravity. It was demonstrating extreme physics driven by the very water loss laws we had just confirmed. The cooked crust theory, a deeper question remained. Why was it so active? New research suggests that interstellar objects aren't pristine fossils. Instead, they are cooked. During billions of years in the vacuum between stars, they are bombarded by cosmic rays that penetrate the ice and restructure the chemistry, creating a radiation-hardened crust about 20 meters thick. What we witnessed was not a primordial heart, but this ancient, processed skin peeling away under solar heat. This explained the bizarre chemical ratios, such as the massive abundance of carbon dioxide, which was 60 times higher than typical comets. The internal chemical engine, the presence of nickel and iron in the coma, provided the final clue. These metals act as catalysts. When water melts within the porous, hardened crust and hits these metal grains, it triggers exothermic reactions that release heat. This creates a feedback loop. Heat melts more ice, pressure builds, and eventually, the surface ruptures in violent jets. This cryovolcanism explains the brightness spikes and the object's resilience. It wasn't an engine in the mechanical sense. It was a natural chemical engine forged by eons in deep space. The final stress test as the visitor speeds away. One final encounter remains. In March 2026, it will pass near Jupiter. While it's moving too fast to be captured, Jupiter's massive gravity will provide one last gravitational stress test, potentially tweaking its rotation or triggering new internal shifts. If the Juno spacecraft is still active, we might get one last look. This flyby is our final chance to see how an interstellar body reacts to the most powerful gravitational environment in our system at a lasting impact regardless of what happens next. This visitor has changed everything. It proved that interstellar objects are not static relics, but are active, evolving bodies shaped by the harsh environment between stars. It showed that complex chemical engines can drive extreme behavior without needing exotic explanations. It reminded us that the void between stars is transformative, a place that hardens and rewrites the material passing through it. Such an Atlas has forced a rewrite of the textbooks. It wasn't an alien craft, but it was a survivor of a journey we are only just beginning to understand. As it disappears back into the dark, it leaves us better prepared for the next visitor that dares to cross our path. Would you like me to focus on a specific section to make it even more concise, or perhaps adapt the tone for a different type of audience?